Alright guys, so in our next problem, we're still solving for current by the way, so we're I. So let's read our next problem. A current flows and charges a capacitor by 5 millicoulombs. That's millicoulombs by the way, milli for M. It took half a second to fully charge the capacitor. What is the value of the current? So what does all of this means? This means, we can try to draw this diagram or whatever. So this is a circuit, right? Because it's a capacitor or whatever. So we can draw the circuit over here. So again, this is the battery. And these two lines over here, that's called a capacitor. Don't really worry too much about what exactly a capacitor is, but just know that a capacitor basically has the ability to sort of store charges. So anyway, let's get back to it. It says that a current flows and charges a capacitor by 5 millicoulombs. And all of that happened in half a second. That means that 5 millicoulombs went inside, or at least passed through the capacitor, and all of that shit happened in half a second. So let's try solving this. What's our given? So first things first, we're given the charge, right? 5 millicoulombs. So our charge is equivalent to 5 millicoulombs. That's right over here. Next, we're given the time. It said it took half a second. Now, what is half a second? That's 1/2 of 1 second, or 0.5 seconds, because that's literally half a second. And it also asked us to find the value of the current. So I, which is current, we don't know what that is. So let's try to solve this. Before we start to solve any of these, remember that in the equation for the equation for the current, it just uses coulombs and seconds. So we have to convert this millicoulombs into coulombs. So how do we do that? So first we start with 5 millicoulombs, right? And we convert that into our regular old coulombs. So what you can do is, I really shouldn't be teaching you guys this, because you guys should know how to do this by now. But anyway, we've got 5 millicoulombs, and we can just pretend that this is just a fraction divided by 1. Because remember, any number divided by 1 is just itself. And we multiply that by something that lets us convert it, or lets us cancel the millicoulombs into coulombs. So where is the millicoulombs here in this fraction? Is it on top or is it below? It's on top, right? Which means that the fraction we have to multiply it to convert it has to have the millicoulombs below. Because look, they're on opposite sides, right? And therefore they cancel. So the millicoulombs, they cancel. And for every 1 millicoulomb, how many coulombs are there? So again, milli is just 1,000, but backwards, like in the decimal places, right? So that's just 1 times 10 to the power of -3. So for every 1 millicoulomb, there are 1 times 10 to the power of -3 coulombs. So put that in your calculator, and you end up with 5 times 10 to the power of -3 coulombs. So now we have the charge, and we also have the time in seconds. We can now calculate for current. So what's the solution? The formula for current is charge divided by time. So we put our charge over here on top, and we put our time here and below. So 5 times 10 to the power of -3 coulombs, which is what we solve for here, divided by our 0.5 seconds. Put that in your calculator and you'll end up with a value of 0.01 amperes. And therefore, our answer is the current is worth 0.01 amperes. Because remember, it did ask us what is the value of the current. So the value of the current is 0.01 amperes.